Hello physicists and welcome. In this session we'll be looking at both graphic and numeric ways of calculating initial momentum, impulse or change of momentum, and final momentum. Let's get started. In our situation we have an apple, a mass 0.25 kilograms and a weight of 2.5 newtons is tossed straight up at a velocity of 15 meters per second. By graph and calculation, determine the final momentum and velocity of the apple 4 seconds after it's tossed up. Hey, got my initial sketch here. Force on the apple is going to be downward, 2.5 newtons. That's the force due to gravity. Afterward, I'm making a bit of a guess that probably the apple will be heading back down, but I have a sketch there. Maybe it'll be up, maybe it'll be down, but we'll find out. Hey, I can represent my initial momentum by either just multiplying velocity times mass, or I can represent it as the area of a velocity mass graph. So let me go ahead and label the axes here. So on the velocity, I have upward as being the positive direction and downward as the negative direction in meters per second. And my horizontal axis, mass in kilograms. I've arbitrarily decided to put 0.1 kilogram divisions because I have to cover about 0.25 kilograms. Hey, let's go ahead and calculate that total momentum. My total momentum will be represented by the area of this rectangle, which will have a height of 15 meters per second and a width of 0.25 kilograms. We've done that graphically. Let's go ahead and do it numerically. I know my initial momentum is my mass times my velocity. That's equal to 0.25 kilograms times 15 meters per second. I get the final value of 3.75 kilogram meters per second. Remember, I have to multiply my units as well as multiplying my numbers. Let's take a look at the impulse applied. Okay. Again, I can represent that as the area of a force versus time graph. I've labeled the force where an upward force would be positive, downward, which is the way that gravity acts, would be a negative force. And I've got time along the horizontal axis. Hey, I've set this up to go from 0 to 4 seconds, the period of our application of that force. Let's go ahead and graph that. All right. Hey, because I have a negative force, I end up having a rectangle that has a negative height. It's below the x-axis and extends to the right 4 seconds. Let's go ahead and we'll calculate that impulse numerically. And I know that the impulse is represented by the letter J, which is the force times the time. Going through and calculating that, that's minus 2.5 newtons times 4 seconds gives me an impulse of minus 10 newton seconds. Let's unpack that newton second and see what that actually means. Hey, newtons times seconds. If I unpack the newton, I find out that it's a kilogram meter per second squared. How do I get that? Refer back to an earlier video, but briefly, a newton is the amount of force needed to accelerate a mass of 1 kilogram at 1 meter per second squared. Well, that value I'll multiply times seconds. So I have seconds on the top and seconds squared on the bottom. I can cancel a couple of those, so I end up with a kilogram meter per second. So saying newton second and kilogram meter per second is describing the same situation, just using different units. Hey, let's take a look at our final momentum. And I know my initial momentum plus the change of momentum is equal to my final momentum. Hey, so that change of momentum comes from an impulse, which is my force times my time. Hey, let's go put some numbers into it. You'll find that I'm going through the numeric calculation here for total momentum, and I'll come back to the graph. I find it a little bit easier. So I'll find my initial momentum, 3.75, plus the negative 10 newton seconds. And I know those are the same units as a kilogram meter per second. Put that together, I get a minus 6.25 kilogram meters per second. Hey, so we know that's the product of mass times velocity, and we're looking for velocity. We've solved the first problem that we're looking at. Hey, what's the final momentum? We've got that, minus 6.25 kilogram meters per second. Hey, and so that's equal to mass times velocity, my mass 0.25 kilograms, times that unknown value of my velocity. Hey, so I could say minus 6.25 is equal to 0.25 times what number, or divide each side, and I find out that the value is minus 25 meters per second. So my final velocity is going to be a downward 25 meters per second. Let's go ahead and put that in graphic form. All right. Hey, so again, I'll label this graph velocity on the vertical axis, positive upward, downward negative in meters per second. And again, I'll use the horizontal axis in mass in kilograms in 0.1 kilogram increments. Hey, so I can represent this final momentum as a rectangle having a height of, I call it a negative 25 meters per second and a width of 0.25 kilograms. Just note about the graphic method. The graphic method, or with these graphs, is just to help you visualize what's happening. We have a positive value to start off in our initial momentum. We have a negative change of momentum or a negative impulse, and we've ended up with a negative final momentum. We could also do this through the numeric methods as well. So for now, that's page 9 in the packet, and physics.